Good morning to all. Today we are going to see about the construction of optical fiber cable. Here in this topic, the outcome of this topic is after completion of this section, the students are able to explain the construction of optical fiber cable. This is the diagram for the fiber optical cable. An optical fiber is a glass or plastic fiber that carries light along its length. Fiber optics is the overlap of applied science and engineering concerned with design and application of optical fiber. Optical fibers are widely used in optic communications, which permits transmission over long distance at higher bandwidth than other than from the radio signal other form of communications. Here, an optical fiber is a very thin strand of silica glass in a geometry quite like a human hair. In reality, it is a very narrow, very long glass cylinder with special characteristics. When the light enters in one end of fiber, it travels and it leaves the fiber at the other end. An optical fiber consists of two parts, the core and cladding. The core is a narrow cylindrical strand of glass and cladding is a tubular jacket surround it. The core has higher refractive index than the cladding. The light traveling along the core is confined by the mirror to stay within even the fiber bends around the corner. The fiber optic cable has an additional coating around the cladding called the jacket. The jackets usually consist of one or more layer of polymer. It's the role to protect the core and cladding from the shocks that may affect their optical or physical properties. The jacket also provides a protection from the absorption, solvent and other contaminants. The jacket does not have any optical properties that may affect the propagation of light within the fiber optic cables. The guiding mechanism in the optical fiber. The light ray is injected into fiber optic cable on the right. If the light ray is injected and strike on the core to cladding interface at an angle greater than the entity called critical angle, then it is reflected back into the core. Since the angle of incident is always equal to the angle of reflection, the reflected light will gain the reflector. The light ray will then continue this bouncing path down the length of fiber optic cable. If the light ray strikes the core to cladding interface at an angle less than the critical angle, then it passes into the cladding where it is attenuated very rapidly with propagation of distance. The light can be down the fiber optic cable if it enters less than the critical angle. Thank you.